Hello friends, welcome to my channel all about electronics. Today we will discuss what is diode, how do we connect the diode in the circuit, and what are the applications of the diode. So let's start the video. A diode is an active device which allows the current to flow in a single direction. Now the practical symbol of the diode is shown on your screen and the real component is also shown here. Now if you look at the symbol of the diode, the first terminal is the negative terminal which is cathode, and the second terminal is anode which is the positive terminal. And if you look at the practical component, uh, you will see that there are two colors. First is silver and the second one is black. The black color denotes the positive end of the diode which is the anode, and while the silver color denotes the cathode of the diode. These colors are used for distinguishing the anode and cathode. Uh, if there is only one color, we cannot identify which end is anode and which is cathode. So that will become a great problem in distinguishing between the anode and cathode. Now there are two modes in which the diode is operated. The first mode is forward bias and the second mode is reverse bias. Now in forward bias, when the positive end of the diode is connected to the positive end of the battery and the negative end of the diode is connected to the negative end of the battery. Now the positive end, that is anode of the diode, is made by the material which is of p-type. P-type means they are positively charged particles that are holes, and the cathode of the diode is made by the n-type material which contains the electrons. Now the p-type is connected to the positive end and the n-type is connected to the negative end of the battery. So as p-type contains the holes, so holes are repelled by the positive end while electrons are negatively charged, so they are also repelled by the negative end of the battery. So holes tend to move from left to the right, okay, and the electrons tend to move from right to the left. So due to which the depletion region becomes narrower, that means it becomes thin and thin. Now the reversed bias of a diode. The diode is said to be in reverse bias when the p side, that means anode of the diode, is connected to the negative end of the battery while the cathode n-type end is connected to the positive terminal of the battery. As I mentioned earlier, the p side, in the p side the majority carriers are holes. That means the majority concentration is of holes in the p side while the majority concentration on the n-type is of electrons. So as holes are connected to the negative end here, and you know that the holes are positive charged particles, so holes are attracted towards the negative end of the battery because both of these are opposite in nature. Now in the n-type region, as we know, the electrons are negative in nature because they are negatively charged, while the positive end of the battery is positive. So the electrons are attracted towards the positive end of the battery, due to which the electrons tend to move away from the junction, and in the p side the holes tend to move away from the junction as well, due to which the width of the depletion region in the reverse bias increases, due to which the resistance in the reverse bias also increases. So that's the reason that the diode does not conduct in the reverse biased. Now how do we connect the diode in a circuit? The diode is always connected in forward bias. Now if you see in the figure A, the diode is connected in forward biased, and in the figure B the diode is connected in the reversed bias. Now in the figure A, as we connected the diode in the forward bias, the diode offers a very low resistance, due to which the current easily passes through the diode and hence the bulb starts to glow. And If you look at the figure B, the diode is connected in the reverse bias, as we have connected the negative end to the negative end of the battery, while the positive end of the diode is connected to the positive end of the battery. So due to which the diode offers very large resistance, due to which the bulbs does not glow in this case. Now the application of diode. The very basic application of a diode is the rectification. Rectification is a process in which the AC signal is converted into a DC signal. This process is accomplished very easily by the diode. Now there is an AC signal, as you can see in the figure. Then this signal is passed through the diode, as you can see in the circuit diagram. Now there are two half cycles for the AC signal: the positive half cycle, in which the diode operates in the forward bias, and the negative half cycle, for which the diode operates in the reverse bias. Now for the positive half cycle, the anode is positive while the cathode of the diode is negative. So the current passes through the diode, and we can see the output in the output figure. Now for the negative half cycle, the anode becomes negative and the cathode becomes positive. So the diode is said to be in reverse bias. So it blocks all the voltage through it. So that's why we does not get any output for the negative half cycle. So this is the very basic application of the diode, that is rectification. There are also various application of diode. All these application using the very simple concept that the diode conducts only in the forward biased. So that's all about my video. Please like, share this video and subscribe to my channel all about electronics.